So, linguistic phases of NLP. So, this diagram is displaying all those phases. And the first one is lexical analysis, or you can say lexical and morphological analysis. When I say lexical item, it means a word in a sentence. And when I say lexicon, it means collection of words, which can be a dictionary. So, morphological analysis is the analysis of the different forms of small units which exists in a word. And that small unit in a word is called morpheme. So lexical and morphological analysis, that so now we are talking about that we will analyze the words and the morphemes in it. For example, if the word is kataba, then you have to focus on the pronunciation. Ka, and then pause. Ta, and then pause. Ba is then pause. So there are three morphemes in this word, okay? Ka, ta, ba. So you can identify these morphemes when you pronounce it. And then you will start pronouncing the word and then stop. Start pronouncing the word, then stop. So due to that silence or due to that stop, you can identify that now this is the end of the morpheme. So kataba has three morphemes. So lexical and morphological analysis. What we will do in this phase of NLP? You will find the relation between the morphemes of the word, morphemes of the word. So you will focus on one word, and then you will analyze the morphemes of the word. And is there any relation between them? And if you will study this kind of thing, then you are studying lexical item, you are studying words, and you are studying morphemes. So this is the first phase. This is the first phase in the linguistic phases of NLP. What you will do in this analysis? You will take that word from the text, you will convert it into its root form by using lemmatization, not stemmer. Stemmer is not giving you the meaning. By using lemmatization, you will convert it into the root form, and then you will assign the part of speech tag to this word. And for that, you can consider the dictionary in which you have all the words with the meaning, etc., etc. And that meaning will give you the understanding what would be the tag of that word. Part of speech tag means noun, adjective, what tag you want to give to that word. So this is the purpose of lexical and morphological analysis. Not only this, you can discuss also the different inflected forms of that word. You can also, if that word is a verb, you can also discuss that what is the tense of that, what is the tense used in that word. So for example, if the word is incoming, then you will, okay, what would be the uh, root of this word? Maybe in, maybe come, incoming, maybe the root is come, but here incoming, this is an adjective. You are assigning the part of speech tag to it. And incoming has three morphemes: in, ing. Okay. So the same rule here for Arabic, for English, for all languages. So more, how to identify the morphemes? You can identify it through speech by speaking it, and then you can identify what are the pauses in it. Those pauses will give you the idea that it has how many morphemes. So incoming has three morphemes: in, come, and ing. And this come can be the root for the. So if you will study something like that, then that would be called lexical and morphological analysis. Number two, the syntactic analysis. We already talked about syntactic analysis or syntactic parsing in the previous steps. For example, one of the parsing, syntactic parsing is this dependency. And for example, when I talked about this syntactic parsing, I said something about syntactic parsing. And now it is again syntactic analysis. Syntactic analysis. And in the syntactic analysis or in the syntactic parsing, what you will do, what you will analyze, you will analyze the grammar. You will check the grammar. You will analyze the grammar. You will have some sentence. And then in that sentence, you will check the grammar of that sentence. And then you will show the relationship between the words and also between the phrases. And also between the phrases. It is not mentioned here, but you can say it. So if a sentence is given to us, then if we are going to check the grammar and we want to show the relationship between the words and phrases, this is called syntactic parsing. This is called syntactic parsing or syntactic analysis. And there are two kinds of syntactic parsing. One is constituency parsing, other is dependency parsing. We have already seen the example of dependency parsing. This is the exact example of dependency parsing. This is the exact example of dependency parsing. We have already seen here. I can copy this example here. I can copy this example here. But here the dependency parsing is displayed like that. In this figure, this is for the dependency and this is for the phrase or constituency parsing. Constituent, phrase, chunk, almost similar concepts, okay? Almost similar concept. But I will go with the phrase for syntactic parsing. Or I will go with the constituent or constituent for the syntactic parsing. Chunk, it can be one phrase, sometimes it can be two phrases or something like that. So that's why, but some authors are using also chunking also for the phrase. Anyhow, leave this discussion aside. Constituency and phrase parsing is same thing. Dependency parsing is another thing. Here, if you will see, this tree is illustrated the constituency relation. So if you will say this tree is illustrating. So this and that is, these are the verbs. And then this tree and the demonstrative pronoun. Ism ishara, huh? Ism ishara is a Arabic word, huh? Demonstrative pronoun. So this is the demonstrative pronoun and the tree is noun. So they are making, this is noun, this is part of speech, this is demonstrative pronoun, making noun phrase. Due to this head word tree, making noun phrase. So I will come here on these verbs later on, but first I'm going towards this phrase. This tree is illustrating the constituency relation. So you know that constituency relation and this is a combined word, huh? Combined word. So this is a combined phrase, you can say. So constituency is adjective to this relation. Relation is a noun, and this constituency is adjective of that noun, and this is determiner of that noun or article of that noun. And then due to this main verb, due to this main noun, this is again noun phrase. Second noun phrase, NP2. There is no need to write it NP1, NP2, just NP. And then this tree is illustrating what? This relation. So now you can make a new phrase, verb phrase, which is containing this verb illustrating and this noun phrase in it. So this is one constituent, this is one phrase, and now it is This is the tree for another phrase. This is one phrase or constituent. This is another phrase or constituent, but it is a verb phrase due to this verb. Because illustrating what we are considering this verb here, that's why we are making this verb. Noun phrase we have already done. Now this tree is illustrating. So this tree, now this verb phrase and this is a verb and it is again making a verb phrase. This is another constituent or another phrase. So how many phrases? One, two, three, and this one four. And this S is the root of the tree, and this NP and VP under it. So if you will make some tree like that, this is called constituents, constituent parsing, or phrase parsing, or phrase parsing. Huh? This is the example of that one. Constituent or phrase parsing. And this is example of dependency parsing, but the tree is given in different form. Normally, this is the right form for the dependency parsing, in which you are showing it with the arrows, in which you are showing the relationship or dependency with the arrows. And in dependency, root is always verb, the main verb of the sentence. You have to identify the main verb of the sentence. That would be the root of that dependency parsing tree. So this is a kind of a tree, not exactly, but this is the exact form of the dependency parsing. Now here, if you will think, this is the same example. This is tree. So this is determiner, tree is noun. Here we are not making here constituent. Is the verb. This is the main verb of the sentence, which is at the root position. And then illustrating, and here the dependency relation, determiner, adjective, relation is noun. So here we are making a noun phrase. And then this illustrating is a verb. And then we are connecting it. So here you have also a kind of a tree, but here you are not following the constituent rules. You are not making constituencies. Huh? You are only saying that this. So it is better to show something like that is, or you can say this, the dependency, or you can draw arrow here, or if undo is not here, if I will do that, the whole drawing will go on. Okay. Illustrating the relation, and then the tree is illustrating, or the tree is this is the subject. I can write subject, non-modifier, or something like that. And this is what you can write it, a root. According to that previous annotation, according to this annotation, if you want to draw the dependency parsing tree, so that would be like that. Or you can draw like that. Again, it is not our objective to understand how we can draw these trees. No, our objective is to understand that there is some phase, second phase, which is a linguistic phase, exists in NLP. And what is that? Only we have to get the understanding. And then you can say that there is a syntactic parsing phase of the NLP. And in that syntactic parsing, we normally study, or we normally analyze the sentence grammar wise, and we normally analyze that which word has the relation with which word, or we normally analyze that which phrase has the relation with which phrase. And then you can give these examples or you can say the example is constituency parsing or dependency parsing. And this is the tree for the constituency parsing or phrase parsing, and this is the tree for the dependency parsing. And I told you that this is not the exact dependency parsing. This previous picture is better example for the previous for the dependency parsing. But anyhow, here you are also making the verb as a root of the tree. So okay, that concept of dependency is also there. So it's up to you. So now the third part, semantic analysis. Semantic analysis. Mainly in linguistics, when you are going to identify or analyze the semantics in a sentence, then it has different meaning. Then it has different meaning. So here semantic analysis will focus on what? Literal meaning of the words. The words that you have there in the sentence, what is the literal meaning? What is the meaning of that word? Not the intent. Intent is something, the intention of the human being who is saying that sentence. What is the intent? That is different. I gave you the example yesterday. But it is what? Literal meaning of the word, actual meaning of the word that you used here, or the actual meaning of the phrases, or the actual meaning of the sentence. So if you have to go, if you have to identify the literal meaning of the words, phrases, or the sentences, then this is something you are doing semantic analysis. For example, if you are doing a word sense disambiguation, so you can use this semantic analysis in word sense disambiguation. What is word sense disambiguation? I already defined yesterday. What is that, Shanwar? Word sense disambiguation, what it means? Hmm? What is the meaning of this word sense disambiguation? Qaid, Murtaza Qaid, Qaid-e-Azam. He's also saying the same thing. What is word sense disambiguation? Muaz, Al-Karaj, same. So I told you yesterday, yeah, it's something like that. That's in languages, sometime one word can have more than one meaning. And when you, so if you have one sentence in which you are using this sentence, it is giving some other meaning. And here in this sentence, it is giving some other meaning. But humans can understand, but machines, how they will understand? So how they will disambiguate, how they will differentiate the meaning of the words, how they will differentiate the sense of the words. This is called word sense disambiguation. This area of NLP is called, there are many areas. This area is called word sense disambiguation. So, so you can do this semantic analysis for this word sense disambiguation, or if you want to extract some relationship in a sentence between words or between phrases, you can also you can also you can also use this semantic analysis. For example, here, sentence semantic analysis is a topic of NLP which is explained on the Geeks for Geeks blog. So semantic analysis is main verb is. Semantic analysis is a topic of NLP. This is, you can say, one sentence. So so then this is the subject and this a topic of NLP, and that this NLP can be an object. Topic of NLP is kind of an object. And then which is something conjunction or relative clause, which is explained on the Geeks for Geeks. Which is explained means this semantic analysis is a topic of NLP, which is explained in on the Geeks for Geeks. So this topic is explained on Geeks or Geeks for Geeks, the website. So if you will do some semantic analysis of over it, then you will have some, this is one entity, which is a subject, is a topic. This is another main entity, topic of NLP. And this topic is explained on which platform? Geeks for Geeks. It is also a some major entity. Major entity, some major unit, huh? Meaning wise, this is something main component, you can say. And that's why I am calling it entity. You can say major component in meaning. So with respect to all other words, these are something which are the main things. That's why we are calling them entities. And identifying these main identities. And then, so normally in semantic analysis, what do you normally do? Okay, this is one entity, and this is a topic of, this is a relation, okay? This is a relation with this entity. So this entity and this entity has this relation. So this is called relationship extractor. Or this NLP and Geeks for Geeks. So this NLP is explained on what? So this is the relation which you have extracted from here. So extracting entities and relation between them is called semantic analysis. Extracting entities and relationship between them from the sentence is called semantic analysis, and this is an example of it. And you have Dr. Faisal, who is sitting, who is sharing his office with me, huh? His PhD is in this field, semantic analysis. Okay. Semantic analysis, okay? His PhD is in this field. And then contextual discourse analysis. What is contextual discourse analysis? Context, or shortly, discourse analysis. You will not see the word contextual before with this discourse analysis again, only here. What is discourse analysis? Discourse analysis is if you are dealing with the text and if you are on one sentence, then what is the context of this sentence in the previous sentence? What is the information about this in the previous sentences, and what is the information after the sentences? And if you will analyze something like that, this is called discourse analysis. This is called discourse analysis. So that's why I have written the word contextual discourse analysis, so that you can have an idea that here in this analysis, you are going to see the context of something. And context means something which is preceding and something which is following the current thing. So if you have a sentence, then you have to analyze what is preceding that sentence, what is coming before that sentence, and what is coming after that sentence. You will analyze to do different things. Maybe sometime you are searching for a connection, that this pronoun that you have used here, this means what? So in the current sentence, so you normally do discourse analysis for very different purposes. For example, you are in a current sentence, and in the current sentence, some information is not clear. Then you will go to the previous sentences. Maybe that information is available there. And from that previous sentences, you can identify, okay, this thing is that thing. And then you will identify the meaning more clearly. So if you will, if you have sentences and if you will go to something which is preceding that sentences, then you are invoking the meaning of that sentence more clearly. And sometimes you also check the things which are following that sentence. That is called context. That is called context. For example, this is not true. What is not true? If your machine is understanding what what is this saying sentence, huh? This is not true. Then the word this, how you can identify what it means? This is not true. This is not the name of a person, huh? So then there is a need to go back to previous sentences and to identify what this means is. This is not true. Maybe in the previous sentence, there is some statement which is false or true or whatever. Or maybe there is some fact which is explained there in the previous sentences. So the word this in this sentence depends on the previous sentence, and then you can identify what it means. Or if it is written, this is him, and then again, what is this? This maybe some name Aslam or Akram is written there, and that Akram is the here it means. So that is the discourse analysis, discourse analysis. And then pragmatic analysis. So one more time, what is this contextual discourse analysis? So it depends upon the sentences that precedes it. So for example, you have current sentence, then it depends upon the sentences that precedes which are coming before, and invokes the meaning of the sentences, and it will, so you have this, and you will get the meaning of this sentence that follow it, which are coming next. So you have to look previously, and also you can also see what is coming next if you have. But most of the time you will go previous to the previous sentences. Pragmatic analysis. So pragmatic analysis is the last linguistic phase of this NLP. In this study or in this analysis, you will discover what is the intended meaning of the sentence and not the literal meaning of the sentence. Literal meaning means what is the meaning of that word. Intended meaning is the person who said this sentence, what is his intention, huh? So pragmatic. So if you will discover the intended meaning rather than literal meaning in a dialogue, that dialogue can be in a text form or in a voice data. So if you will discover the intended meaning rather than literal meaning, then this is called pragmatic analysis. For example, can you pass the salt? Can you pass the salt? So literal meaning is pass, walking through something, huh? Can you pass the salt? And if there is salt mountains, huh? Or salty path, can you physically pass into that salty path? So this is the literal meaning. In other words, which means that can you do that task physically? But actually meaning is that you are sitting on a dining table or something like that, and you are asking for the salt, huh? Your friend is sitting close to that, Salt pot. So you are asking to shift that salt pot towards you, huh? So that is the intended meaning. And you can have many examples in Arabic also. So this is just now. So introduction to the NLP is now. I have given the introduction first in the early slides. And now we will go with one algorithm. There are many algorithms, but I have taken the simple one, okay? I have taken the simple one here, which is the minimum added distance. Minimum added distance. So, so minimum added distance or simply added distance, this is an algorithm. And we will use this algorithm to quantify something, to measure something, to quantify something. What is that thing? We will use this algorithm to find that how dissimilar or how similar two strings are to one another or with one another. So we will take two strings and then we will find that how these two strings are dissimilar or similar to each other. And how we will do that? By counting the minimum number of operations. We will count some number of operations, and those operations are called edit operations. And we will use these operations to transform one string into another string. And what is the purpose of this minimum added distance? The purpose of this algorithm is you can use this algorithm for spelling correction. You can use this algorithm for spelling correction. The spelling correction application that you have in the MS Word, when you type, it is automatically correcting. Behind this, minimum added distance is working. Plagiarism detection. You can also build application on this minimum added distance algorithm, and you can build an application which can detect plagiarism. DNA analysis. In the field of computational biology, you can study the DNAs. So one DNA with another DNA. So one DNA can be uh, out of inherited diseases and other with inherited diseases. You can compare and you can find the difference. Where is the difference? And then you can do some surgeries there or you do some modifications there. You can use this algorithm in machine translate for evaluation of machine translation and speech recognition also. For named entity extraction or entity co-reference, etc. But these are the popular ones. These three are the first three are the popular one. Again, what we will do in this algorithm? This is an algorithm through which we can find that how two strings are dissimilar or similar to each other. And how we'll do that? By counting the number of operations. Those operations would be edit operations, and those operations have names. We will see those names in next. So, and through this algorithm, when we will perform those operations, then one string will be converted into another string. Or you can say the source string will be converted into the target string. For example, if you will see here, intention is one string, execution is another string. Normally, when these strings will be given to you, then these stars and this D, S, S, I, S is would not be the part of these strings, okay? This is something after applying the minimum added distance algorithm. This is the source string, and we want to convert, and this is the target string. We want to convert this source string into this target string. And minimum added distance algorithm will do this for you. It will do the alignment. These vertical lines that you have, this is called alignment. It will align strings with each other, the letters of the strings with each other. And where this algorithm will find that here it has to insert letter, it will and then here it is, here star means, okay, if you will see, this is the intention, this is the something. Here it is saying that in the source, this is the source string. And it is saying that delete this I. And when you will delete this, okay. And this I, this is the source string. So this D means delete. Delete this I, and then you will have space here. Huh? Star means space, huh? Empty space. And then, and I have to transform this string to this string execution, or I have to make this string intention to another string execution. I have to make this string execution. This is the objective. And here n, when the letters are different, after alignment, when the letters are different, n and e is different. So here I have to replace this n with e. This replacing is called substitution. Substitution. So that's why S is written here. So one operation is delete, another operation is substitution. And when substitution you have to perform when the letters of the two strings are different in alignment. So T and X different, substitution. Perform substitution. And then this T will be substituted with this X. And here this will become execution slowly. EE same, no substitution, no operation is needed when you have same. And here after alignment, we are inserting space here, and we are basically inserting a letter C here in the intention. In the intention. Actually, we are inserting C here. And then this is operation insert. That's why I is written here. And here N and U are different. So we have to substitute this N with U. So that's why S is written there. Rest is same. So there is no any operation needed. This is after running the algorithm. You will find these things. Huh? You will find these things. This alignment and these operations you will find after the running of that algorithm. But we have seen that, so these are now operations. So deletion, substitution, and insertion are those operations which we were talking about in this definition. In this definition. You can take the cost of each operation as 1, and then here 1, 2, 3, 4, 5, and then the distance would be 5 in this example. In this example, total distance of operations. By summing them up, if the cost is 1 for each operation, then summing them up, you will have the cost 5. But if you will apply some Levenstein method, then in that method, substitution has the cost 2. Deletion and insertion has cost 1. Substitution has cost 2. And then 1 plus 2, 3 plus 2, 5, 6, and plus 2, 8. Then the total distance would be 8, according to Levenstein method. You can also do this thing in computational biology, and these are the, you can say, 2 DNAs. So these are the 2 strings of DNAs, huh? And after running the algorithm over it, you will have some kind of alignment here. This is what it means. We are inserting. This is the source string of DNA. This is the target which we want to make. We are inserting this T. And then here we are deleting this G. Because you have to see. And here we are deleting. These two are different, so we are substituting, deleting, substituting, inserting. We are getting the introduction first before we will start the algorithm. So we can apply. So here just we have two example. One is this one with the strings and one is again with the strings, but these are the DNA string. Now the question is how to find the minimum added distance. So we have to find a path. That path would be the sequence of added operations. And what would be that operation? Substitution, insertion, deletion. Huh? So we have to find a path. That path would be a sequence of operations or sequence of added operations from the beginning state to the end state. I'm not saying string because we have two strings, huh? So you can from the beginning stage to the final stage, you can say. So then what would be the initial state? The initial state would be my source string or the source word. The word that I want to transform, the word that I want to convert, that would be my initial state. Then I will perform some operators, which would be operations or operators. These would be my. Uh, so this is a kind of a problem definition that you have done for the previous problem. So initial state, and these operators means actions. So what are the actions? Insert, delete, and substitute. And what is my goal? The word where I want, the word with where I want to reach, or the word or the string where I want to reach. For example, in this is initial stage and this is goal state. The word we are trying to get to, the word where we are trying to reach, and the path cost. Okay, path cost, this is the cost. This is also one method. This is also one method. Yes. Implementation and explanation. What? Yeah, yeah, this is the slide now. Yeah. The goal is to reach at the string execution from the string intention. Not identical. No. Identical is not the goal here. We have this string, okay? You have to make this string execution. This is the source string and this is the target string. Path cast. So path cast, it can be one, it can be two by Levenstein method. So you can use any method and then you can calculate the final path cast for the whole path. And you want to minimize. Your name is what? Innocent, okay. And you want to minimize the distance. So what is your name? At least give me your name so that if you are going out.
And maybe we'll come back before the test.
Isa, okay. So you will calculate the total path cost from path from the initial state to the end state. And we want to minimize that path cost. That's why it is written here. We want a minimum path cost, not you will have some paths with the higher path cost. You will have some other solution also with higher, but we want the solution with the minimum cost or with the minimum number of added operations. It also means minimum number of added operations. Okay, now this is the algorithm. First read this algorithm. Algorithm is easy. In understanding, in reading, it is easy, but it is lengthy only. So the name of the algorithm is min added distance or minimum added distance. We are passing a source string and the target string into it, and it will return us minimum distance of the solution. And here we are calculating the length of the source string and putting it into n, and then we are calculating length of the target string and then putting it into m. So then after that, we can create a two-dimensional matrix, which we are calling it distance matrix. And we are naming that matrix distance, which has n plus 1, comma, n plus 1. This is the index. So now this is a matrix. If the length of your source is 5 and target is also 5, then you will have a matrix distance 6, 6 here, 6 rows, 6 columns. 6 rows and 6 columns. This two-dimensional array will be created. And then you have the initialization step. This whole is initialization step. Initialization step, what it is doing, 0th row and column is the distance from the empty string. So this initialization will do what? Here we are calling this distance the D, yeah, okay? This is D. And so we are now D00 is equal to 0. D00 means 0th row, 0th column is 0. Look at here. This is something, for example, if your string is this intention 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is the length. Execution 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is the length. So 9 and an n plus 1 means 10 by 10. So it means here 10 by 10 and D00 is equal to 0. Okay. So this is 0th row, 0th column. We are putting 0 here. We are putting 0 here. We are initializing it with 0. Okay. Now, for each row I, from 1 to n, and then n is your 9, huh? For each row I from 1 to 9, do what? Do this statement. Okay. Now I is 1. So D10. D10 means first row, 0th column. First row, 0th column. So this is the row, first row. And this is the 0th column. So talking about maybe this thing, huh? We will see. So the value will come here from this right-hand side. And what it is, what this right-hand side is saying, so I is equal to 1, so 1 minus 1, 0. So D00, the value at the 0, 0 is, what is that value? 0. In the matrix, we have the 0 value here. In the matrix, 0, 0, we have this value, 0, 0. So take this value 0 plus deletion cost and delete the source from the source string, the letter I. The value I is 1. So from the source string, delete the first letter. Delete the first letter. Okay, you don't have to think too much. We will delete. But the cost would be what? 1. Okay, delete that. Deletion cost is 1. So 0 plus 1. Here you will have 0, huh? From this, you will have the value 0. And then from this, you will have 1. So 0 plus 1, 1. 1 is stored here in this D10. So that's why 1 is written here. And we are saying we are going to delete this I. We are going to say that we are going to delete this I. And after executing that statement, you have the value 1 here. 0 plus 1, 1 here. Or you can say 0 plus 1. Because the next step is deletion or insertion, whatever. 0 plus 1, you have 1. Okay. So this is, and now going back. And then I will become 2. And then you will have what? D2 minus 1, 1. So D10. D10 is what? First row, zeroth column. This is first row and zeroth column. Now taking this value, fetching this value, huh? So 1. So, so from here, now not 0. Now we have 1 here. And deletion cost would be what? 1. So 1 plus 1, 2. And that 2 will be stored here at D20. Second row, zeroth column. Second row, zeroth column. Here, 2 will be stored. Easy way is starting from 0. And then after deletion has the cost 1. So in the previous value, add 1 and then you will get 1. In the previous value, add 1 and you will get 2. Huh? In the previous value, 2 plus 1, 3. 3 plus 1, 4. 4 plus 5. 5 plus 1, 6. 6 plus 1, 7. 7 plus 8, 9. 8 plus 1, 9. So this whole loop will do this thing. And it will fill this column with these values. And now, the second, for each column J, from 1 to M is 9 again, from M1 to 9. And then when J is 1, then D0, when J is 1, 1 minus 1, 0. So D00 is 0, huh? D00 is 0 initially. And insertion cost into the string target letter J is 1. In the target string, put this letter. Insertion cost is what? 1. We don't have to think what is we are inserting, leave it. But insertion cost is what? Insertion cost is what? 1. So 0 plus 1, 1. And you are going to store that 1 here. At position what? 0. And the value of J is what? 1. 0, 1. 0th row, first column. So this is 0th row and first, this is the first column. And here you are going to store that 1 here. So insertion cost is 1. So previously you have taken the 0 plus 1 and you are getting this 1. And again, from the previous value, you are getting this previous position plus 1, you are getting this. From previous adding 1 into it, then you are getting this value. From previous value is 3, adding 1 into it, you are getting 4. And in this way, you are going on up to the end. This is how, who is doing this statement, who is doing that thing. This statement is responsible of, of calculating all these values. This statement is responsible for calculating all these values. These values and the previous statement, the previous loop was responsible for that. Now, recurrence relation. Now, recurrence relation. I am here now. So here you have two nested loops. First is for each row I from 1 to n, the same loop. Second is for each column j from 1 to n, the same loop. Repeated here. And here it is the body of the loop. This whole is the body of the loop. And you are calling what? D distance, the same distance ij, dij. And initially I is 1 and j is also 1. I and j is 1. So 1, 1. So we will calculate something on the right hand side and then we will store it here at position 1, 1. What is 1, 1? So this is first row, first column, first row, first column, and this is that position. Here we are going to store that value. This value is already displayed there, but who will calculate this? Who will calculate this value? You will see this from here. This statement will calculate this value. What this statement is saying, min. This min is the mathematical function, not calling to this function, okay? This min is the mathematical function which will give you the minimum value, huh? And in this min is starting from here and it is ending here. And it has three statements, 1, 2, 3. The first one is d I minus 1. I value is 1. So 1 minus 1, 0. 0, j is 1. So 0j, d0j. Take the, what it means, take this value and add deletion cost of this letter from the source. This is the meaning of that statement. So d0, 1. 0th row, first column. Take that value. What is that value? Let's have a look. 0th row, first column. Take this value, huh? Which is 1. So I can say write 1 and then the deletion cost of source I. In the source, delete this first letter. Delete this first letter. So which means delete this first letter, huh? Delete the in the source. This is source and this is string. Delete this first letter and the deletion cost is what? 1. And that previous one and the deletion cost. And that previous one and the deletion cost 1, it is giving me 2. It is giving me 2. It is not finalized yet because there are 3 statements. You have to calculate 3 statements. And then in the next, d I minus 1, 1 minus 1, 0, 1 minus 1, 0. So d 0, 0. Take the 0, 0 value from the matrix. 0, 0 is 0, huh? So 0, 0 is 0. And substitution cost. And replace the letter I in source at target string at jth position. At jth position. Or replace this letter in the source with the letter jth in the target. In the target. So now this is substitution. So now what it is saying here, I is 1, j is 1. So we have seen deletion also. Now this is 1 and also this is 1. We have calculated cost with the deletion and now we are calculating cost with the substitution. And if we will do the substitution for these two letters at 1, 1, that would be what? 2. The substitution cost would be what? 2. For this cost would be what? 2. So 0 plus 2, you will have the 2 here also. And similarly, d 1 and 1 minus 1, 0. So d1, 0. First row, 0th column. What is the value there? First row, 0th column. This is the value, huh? 1. So here we have 1 and insertion cost in the target string and with the letter jth letter. J is 1. So insertion cost is 1. So 1 plus 1, it is again 2. What is the minimum value between these 3 2's? So minimum value is 2. So now that minimum value will be stored here at D11 because the value of I is 1, J is 1. So 1, 1 at 1, 1. 1, 1 is what? This is 1, 1. And that 2 is written here due to that formula. Due to that formula. And you will keep on doing that. So this loop, the inner loop is going from 1 to 9. Now the j will become 2. I will be 1. J will become 2. I is 1. Now j is becoming 2. Which means ith. I is for the row. I is 1 and j is now becoming 2, which is this. So now we are going to calculate this value. In a similar way. By using the same equation, you will calculate this value. And similarly, you are calculating the next. Now J is 3, now J is 4, now J is 5, now J is 6, and you calculated this. Suppose J is 7. Suppose J is 7. We are going to see that. Suppose J is 7 and I is 1. Huh? J is 7 and I is 1. Okay. So suppose J is, I is what? 1 and J is what? 7. So I minus 1 is 0, J is 7. 0, 7. What is the value in the 0, 7? What is the value in 0th row and 7 is this? You have this value, huh? 7. You have this value 7. Now you have to consider directions. There is another concept not written here in this algorithm. So we are going to calculate value for this cell, huh? But we are considering something at that at this position, huh? At this position. Values can come from here, values can come from here, or values can come from here. This is what that deletion, insertion, and substitution means. We are going to calculate this value, huh? And this value can come from upper side, this value can come from this diagonal, or this value can come from horizontal position. Horizontal cell, okay? Which is connected with that cell, which is connected with that cell. So now, so this formula is written here. So I don't have to go back, huh? Insertion means one cast, deletion means one cast, and substitution means, so this is for, so whatever it is, I minus 1 and j plus 1. This is I minus 1 and j, deletion cost 1. So I have written it directly. And I and j minus 1 plus 1. So here I and j minus 1, insertion cost, that is 1. It is written here. And d I minus 1, j minus 1. This is that condition plus substitution, then plus 2 if the two letters are different in strings. And if letters are same, then the cost would be 0. Then the cost would be 0. What it means? What it means, for example, this letter and that letter, if they are different, then substitution cost is 2. And if, for example, here n and the n letters are same, substitution cost 0. This is what it means. Anyhow, removing this. Now I want to calculate this value. And here the I is, my I is 1 and my j is what? 7. And then I minus 1. I minus 1 means 0. J is 7. So 0, 7. D07 is this value. Plus 1. So 7 plus 1, I will get 8 from here. And then D, I, J minus 1. I is 1 and J is 6. 1, 6. So 1, this 1th row, and 6. 6 is this value. So this is again 7. So 7 plus 1, it is giving me 8 again. And then I minus 1 is 0 and J minus 1 is 6. So 0, 6, 0, 6, 0, 6. 0th row and 6th value, this one. It is giving me what? 6 and plus 2 if S1 into I and S2J are different. I is 1, J is 7. So I1 means first letter in string. This is that one, first letter. And jth letter, which is 7th letter in the target. 7th letter is what? This one. It is same. It is same. So substitution cost is what? 0. So then this process will give me what? 6. That's why the 6 is written here, which I have removed. Huh? That's why this 6 is written here. Okay. And when these and when this loop will execute, hmm, you can calculate these values. And now in the next row, the value of I is changed. And the J will start again, J1, J2, J3, and so on. And in the next row, the value of the I is changed and the J is start again, inner loop, J1, J2, J3, J4, J, and so on. You are calculating these values like that up to the end, up to the end. One thing is not mentioned here. So the last value in the corner that you will get here, that would be the minimum added distance. That would be the minimum added added operations to convert this source string into this target string. But there is some information which is not mentioned here. What is that information? Direction. If we will have direction, then we will have the alignment. This alignment, which is aligned, that this letter is aligned with that, this alignment, and the operations. What operations we have to consider? Deletion. So if you will set those directions in the algorithm, here after this step, you can set directions that the value is coming from the upward, that the value is coming from the top cell, or the value is coming from the diagonal cell, or the value is coming from the horizontal cell. If you will set these directions, then the things would be easy for you. Then you will have the alignment, and also you will have the optimal solution among all the available solutions, because more than one solution is possible in this algorithm. So what you can do, you can either do the backtracking, you can go back, or when you were executing this algorithm at that time, after this step, you can insert pointers. You can insert pointers. For example, these loops, when you have this operation there, you can also insert these pointers ij, dij, here ptrij, and left, down, diagonal. Left is from the left side, down is from the top to down, and diagonal is diagonal. Huh? You can insert these things in another array. And when you will do that, then you have this alignment, which letter is aligned with which, and then you will have also the number of operations, deletions, substitution. What is the sequence of that? Then you can track. Then you can backtrack. When you will have that final value, when you will have that final value here, and if you have the directions written in all the cells, then you can go back, that what is the path, go back up to the initial state. How? Let's see that. Now, here we executed the same algorithm, but we also stored the directions. I have given you the idea. I have here, when I was explaining that 6 is now coming, here it was 8, here it was 8, and here it was giving you 6, huh? And the 6 is coming from where? Diagonal. And diagonal is what? Substitution. Diagonal means, here you can see substitution. Diagonal is substitution. And if so, this 6 value is coming from where? Diagonal. Diagonal. This value is coming from diagonal, not from here, not from here or here. Okay. And if you will look here, this 6, this is coming from where? Diagonal. And that diagonal pointer is here. And you have not mentioned any other pointer here. You have not mentioned any other pointer here. And in this way, you can start and you can put all the pointers like that. And when you will reach here, now pointers will guide you. Pointers will guide you that what would be your optimal path. So you are at the 8. This this arrow means, this pointer means diagonal. So this value is coming from this diagonal. And it is again diagonal. So this value is coming from this diagonal. And this is again diagonal. So this value is coming from the diagonal. Yeah, yeah. And this 8 is now so this 8 is coming from the diagonal due to this pointer I am so then you can highlight. So okay, then you will go back to the previous. And this 8, now this 8 can come from the top, can also come from the left, can also come from the diagonal. It means you can go into this direction also. Here it is going in that. The blue line is going to that direction. But here we are saying we can also go into that direction because pointer toward the top is mentioned. And here, uh, if I will, and from 7, it is showing us only towards that direction, huh? And then you will come into that way. And from here, it is going into that direction. So one student can come up with this solution and one other student can give me a path through this way. So more than one solutions are possible. More than one solutions are possible. So, okay, I am coming back to here. So another student will go directly, because he's going diagonally. So again, he's going diagonally. And from here, it is going in that direction. So you will go there. From here, I can go to the left or I can go to the diagonal. Yeah, diagonal means substitution. Left mean it can be deletion. It can be I don't know. I have to focus on the algorithm. I have to focus on the algorithm. Normally, left, because left and insert is almost same. So probably left means deletion and insert mean what is left? Down, huh? So, or you can say here, this left is with that, this down is with that, and this diagonal is with that order, huh? With the if it is with the deletion, then it is deletion, insertion. So take that order. What is that order? Follow that order. In the algorithm, so this is deletion first, and between you have the substitution, okay? So move this at the end then. So to make the orders, because here you don't have the pointers. And then here you can do what? +1 here, and the 2 here if you want to do that. Anyhow, that is not a issue. So similarly, you can go here, and then this 4 is going into that direction, and from that direction it is going here. And then from here you can go here. At last you will reach in the at the initial condition. At the initial condition. Either by that way, either by some other way, you will reach there. So now, how it is giving you the answer. So if you will focus here, that here we are comparing. So this line is initialization. This line is initialization of the algorithm. And how this is coming? Okay, 1 plus 1, 1 plus 1, plus 1, plus 1. That's why arrow is on that direction, huh? This value is coming from the previous, huh? And then these values are coming from that initialization from the previous. That's why arrows is always on the left. And this is insertion, huh? This is for deletion and this is for insertion. So it means that left arrow means insertion, huh? And this upward means deletion. Okay. Because we discussed this previously, so now it is coming into my mind according to that algorithm. So here we deletion cost, and here we added the insertion cost. So now Now what is happening? So, so if you will focus here, 8 and 8 and n and n, n and n both are same, n and n both are same, and so you have to align n with n. You have to align n with n, and there is a substitution. So substitution, or you can go from here. When you are calculating this one, this is the deletion. This is the deletion. So delete that. So delete that I. This arrow in the topward direction means deletion. So I have to delete my I. So here, write your source string, write your target string, and here I deleted. Star means deleted. Or I can write D here. And then after that, now you are here, and in the next, you are getting this 3. And this 3, N with E, N with E. And you can get this 3 from the top, from the left, and from the substitution. And from the substitution. And here I am, according to this blue color, I am taking this value from the substitution. From this substitution. So substitution, and when the two, so I can write that here I am applying the substitution, because according to this blue color, according to this path, I am taking this value 3 from the diagonal, and diagonal is for the substitution. So that's why I can write what operation it is, substitution, because two letters are different. Okay, now going to the next. You have already calculated this matrix, and now it is easy for you to highlight, to identify. Now, if you are at 5, and at 5, this is t and this is x. Previously it was 3, now it is 5, 2 added. So it is giving me a hint that again substitution is used. So again substitution is used, and both are different. So that's why t and x, substitution. And then when I will have again 5, previously it was 5 and now it is 5, it is giving me a hint that if I have got this value from the previous substitution, then maybe the letters are same. The letters are same. So now here you have the E, and here for this you have the E. The letters are same. Substitution cost is 0. So that's why you are getting the same thing. So that's why you don't have to write any operation here. Similarly, next, so this is 6, and here you have E, and here you have C. So E and C, but 6 you are getting from the left side. Left side is insertion. Left side is insertion. So that's why here you have inserted, in the intention, you have inserted space, and you are inserting this C. You are inserting this letter C here. And here you can write I. And in this way, you can go on like that. And finally, you will have some answer like that, DSS. So you have highlighted also the operations, and it is also giving you the alignment. Okay, it is also giving you the alignment. You don't have to, that algorithm is giving you that alignment. That algorithm is giving you that alignment, that here you have to insert, here you don't have to do anything. Because you are considering these letters with that. And in this way, you can go on. How many students have understood this algorithm? Raise your hands, please. Oh. If you don't understand, that is good, because this you are hiding behind these screens because you want to do your other stuff. So how many students in this line? Raise your hand, please. 1, 2, 3, 4. 3 only. This is not a difficult algorithm, but there are 6, 7 students who are sitting silently. Who are sitting silently. If I will go further like that, I reached here, I reached here. This is the simple algorithm. This is the simple first chapter's algorithm from the book of NLP, okay? There is no probability involved in it. This is simple. The things which are something probability based and the algorithm is something a little bit lengthy and complex, then you can say that those things are difficult. This is not difficult. This is just sequential. So now here, when it was C here and here E, and I got 6 from that previous value is 6. Only one is incremented. It means either it is insertion, either it is deletion, because one is incremented. Because one is incremented between this C and E. But here we are getting this value from the left side. And the left side meaning is what? Insert. What is the meaning of left side? Insert. How I am saying that? Because this was the value. After inserting this, I am getting this one. After getting this from the previous value, after inserting, I am getting this. I am getting this. I explained these values when I was explaining this loop and this loop. This loop is deletion cost, and this was giving me these values. And this is insertion cost, written here insertion cost. And when you execute this loop, you will get these values. And when you will see here, in these values, you have the arrow on the left side. And in these values, you have arrow on the top direction, towards top direction, towards top. And then I can say this arrow which has the direction towards top, it means deletion. And which has the arrow which has the direction towards the left, it means insertion. Insertion and deletion has the cost 1. Substitution has the cost 2. And here, from 5 to 6, I can say previously the value was 5. Only 1 is incremented. It means that if one is incremented, then it can be insertion or the deletion. But the value is coming from the left side. What it means? Coming from the left side, it means it is insertion case. It is the case of insertion. So it means that after this E, oh, this is my source string, okay? This is my source string. So I am here at E. So it means that after this E, this is my source string, I have to insert space. And space means star symbol. And what is its respective? The respective character is C. So then I can write star in the intention and C in the target string. This star is matching with that C. So this is the case of insertion. So what it means, we are inserting C in intention. Actually, we have only one string. And the target string is, we are only using for comparison in the algorithm. And then in the next, the next is, I got this value from here. And this I am getting from this diagonal. I can understand through this blue color, which I already have taken this path when I backtracked. So this 8 is coming from this 6. So there is an increment of 2. When there is an increment of 2, it means substitution. Substitution between what? Substitution between this n, because 8 and u. N and u are different. So n and u, this is giving me alignment. Okay, n and u, this is giving me alignment. And n and u are different. So that's why substitution is needed. Substitution operation is needed. And when it will be done, you will have the cost incremented. And after that, you will have again this value, 8 from 8. It is from the diagonal, but there is no increment. Then what it means? Coming from the diagonal, which means the substitution case. but there is no increment. It means the letters are same. It means, okay, then go to there, then this T, and go to here, then this T. The letters are same. So this is the alignment. No operation is needed. Substitution with cost 0 because both are same. There is no need to substitute anything. Again, this value you are getting in that cell. So no, so we are, but I am getting this value from the diagonal, which means substitution. But substitution has what? Substitution between this I and substitution between this I. So this I, it is giving me alignment and there is no any substitution needed. So that's why cost 0, no in, so there is no need to mention any operation here. Similarly for others, no need. And these are only the operations that you needed to convert this source string into this target string. And you know that deletion has the cost 1, substitution 2. So 2 plus 3, 1. So 2 plus 1, 3. 3 plus 2, 5. 5 plus 1, 6. 6 plus 2, 8. So you have that finally 8 here. So this is the answer, graphical answer. And this is numerical answer with the pointers. This is another example. This is the source string, AKIA source string, and this is the target string, Adil. You have to replace this to this Adil, and the values are written there. Arrows are also mentioned there, manually done. Picture is taken and pasted here. So you have to understand it by yourself. And then there are some NLP libraries. So this is just an information. If you will go to this scikit-learn, then this is a machine learning library available for Python, and the people and the students who are doing machine learning with me, they know that we are using this scikit-learn many times in our programs. So this is a library available, built-in programs or built-in classes are there. You can only use them for your purposes, and many things that you can use it here. There is another NLTK. The link is under it. You can click over it. The website will open. So you can click over it and you can have many projects and many libraries and many programs that you can use it for your purposes. Similarly, TextBlock, QP, Spicy. So these are all different libraries which can be useful for your future purposes. You can click over them and you can see what they are. Similarly, question answering, BERT or Spicy named for named entity recognition, semantic similarity. So here you will have the live demos of the projects which are available there with the source code. Okay. You can see all these different things, and all these things are related to NLP. And the next portion is machine learning, and I will start it in the next class.